Hello everyone. Today we will be going over how you could be more productive using the new ETAP 14 capabilities. Thank you all for attending. We'll go ahead and get started here in just a couple seconds. If you have any questions, we will be covering those questions after the presentation. So if you could please stay maybe 5-10 minutes after, and we will be answering your question so that the presentation can continue to move on. The presentation should probably take about 30 minutes. And again, we will have question and answer afterwards. So let me go ahead and get started. We're going to be going over the new enhancements to the ETAP interface that will help you be more productive on your day-to-day use of the software. There is a new look and feel to the interface. The graphics have been enhanced to be more higher resolution, more user-friendly. The one-line diagram, GIS, and web have been enhanced. The engines have been also enhanced to provide faster speed and performance, overall giving you superior intelligence when doing your power system analysis. I want to emphasize, make sure everyone is aware that ETAP 14 will be a 64-bit application. So it will be able to address larger amounts of memory. So you will no longer have the 2 GB memory limitation that is common with 32-bit software. This highly improves performance. We're also able to now take care of, or able to support multiple core CPUs. So for those of you who have dual or multiple cores on your computer, will be able to take advantage of that. One side item I need to emphasize also is for those of you who will be upgrading to ETAP 14, you want to make sure that your operating system is 64-bit. So whether it's Windows 7 or Windows 8, you want to make sure that you in fact have the 64-bit version of your operating system. In order to access and store and manage larger amount of information, ETAP is migrating from a local access database to a local SQL database that would allow to handle larger amount of data. It'll be more efficient handling larger projects faster, and this is all done behind the scenes. So when you first open a Microsoft Access project in 12.6, 12.5, or any of the existing versions of ETAP, you save that project, you then open that project using the new ETAP 14 version. The migration will be performed in the background automatically. What I like to do now is I want to open the application to show you some of the new enhancements, some of the new look and feel of the interface. So when you install the program for the first time, you could be more familiar. So let me begin with the symbols. the higher quality symbols. As you can see, the symbols have been enhanced. The system manager over on the left-hand side has also been enhanced to better organize your project database. The system toolbar on the left-hand side now comprises of 4 sections. You have the one-line components, which is in essence the components section of the database. This is where you would be able to find the number of buses for a given project. You then have your distribution components. This would be for those projects that use the transmission and distribution modules. You then have the multi-dimensional database folders. This is where you would specify or find your presentations, like your time characteristic curves that you have created. This is where you would also find your configurations. This is where you would find also your study case options. So you notice how all of the information that you're used to managing with previous versions of ETAP is still on your system manager toolbar, except that it has now been broken into 4 main sections. And the last section is rules and library. This kind of brings me into the first feature, brand new feature to ETAP 14 called AutoBuild. To show everyone the new feature AutoBuild, I'm going to give a little bit of introduction. AutoBuild is another way of entering data into ETAP. It is a more efficient, much faster, and user-friendly way of entering a one-line diagram. So for those of you who are creating a one-line diagram from scratch, AutoBuild will give you the capability of building a one-line diagram, an entire system, in just a matter of minutes. So we're going from spending perhaps a few hours creating a 50-bus system to now under just a few minutes. The way that AutoBuild works is by making use of a rulebook. The rulebook contains information about the spacing between elements, either vertical or horizontal. It also contains information about voltage. When you first open a new project, similar to what I have displayed in front of me, there is an AutoBuild toolbar that just happens to be across the top. You want to enable your AutoBuild toolbar, and if you would like to modify the spacing between the elements as well as the voltage levels that will be part of your project. So for example, I have my primary, secondary voltage here, 13.8 and 4160, and my loads connected to 480 volts. So those are the 3 system voltages that I'm going to be working with for this project. I then start at my point of common coupling, or your main incoming, by dropping the source. In this case, our source is going to be a utility. And you notice the toolbar on the right-hand side now is going to take control of creating the one-line diagram. So we never have to leave the toolbar on the right-hand side. After the utility, we're going to have our PCC, or point of common coupling. Below the point of coupling, you're going to have just a medium voltage breaker here. Let me go ahead and get started with 13.8 actually. This is voltage propagation. I actually started my one-line diagram at 480 volts. So what I'm going to do is I'm just quickly propagate the voltage. That's another added benefit of ETAP 14 and AutoBuild, the ability to quickly propagate voltage from a bus into any surrounding elements. So I'm continuing with my one-line diagram. There's my main medium voltage breaker. Below that I have a cable feeding a 2-winding transformer, feeding a switchgear right here. Off of that switchgear, this is now 4160 volts. I need to put a large medium voltage motor. There's a synchronous motor, a lump load, and then I need to model my MCC downstream. So now I will select my 2-winding transformer again. Second 480 volt feeder to my main power circuit breaker and my MCC bus. And you notice how the voltage is automatically selected for us or populated for us based on the rulebook options and the voltage levels that we checked. So now we can go ahead and quickly add our induction motors. Maybe I have a static load. So you can see how we're able to put this system together without ever leaving the toolbar, the element toolbar that's sitting on the right hand side. So that is the just a quick introduction on AutoBuild. Moving forward to new enhancements that are part of ETAP is going to be the ability to display information on your one-line diagram. And the way that that information is presented now on your one-line diagram is by means of using a data block. A data block is a way to customize what is being displayed on your one-line diagram. So for example, if I switch over to my load flow analysis mode, and I want to display, for example, my power flow. For those of you who are currently ETAP users, you know that we have our display options. It's a very comprehensive way of displaying power flow or fault analysis or incident energy. But now in ETAP 14, you'll find that there is a toolbar right next to AutoBuild. It's called the data block toolbar, where you have various pre-created data blocks. So for example, I will go ahead and select my load flow data block. I will apply my data block to the one-line diagram, and you could see that I can quickly display information such as primary and secondary voltage, real reactive power flowing through my 2-winding transformer, the voltage drop through my 2-winding transformer, the loading for a given location, whether it be a switchgear or an MCC. You could also display losses, for example, and all of that is customized using the data block editor. I will go ahead and open my data block editor here. These are all of the properties and result fields, what I'm scrolling through right here, for the bus AC element. If there is an item that you want to display as part of your one-line diagram, then you simply select that element and move it to the right-hand side. So on the right-hand side, what we have here, right, is just a quick preview of the values that will be displayed on the one-line diagram. You now, with data blocks, have the ability also to combine not just the study mode that you have selected, results for the study mode you have selected, but you also now have the ability of combining load flow or power flow results with short circuit analysis results, device duty evaluation results, arc flash, like incident energy. So if you wanted to show power flow and incident energy right on your one-line diagram, that is now possible using the data blocks feature in ETAP 14. The other feature that I want to cover that will make you, I'll go ahead and turn off data blocks here so I can introduce the next feature, is the composite networks. So based on customers' feedback, we have enhanced the composite network element to now be able to allow you to preview what is inside a given composite network. So currently, for those of you who have ETAP installed on your computer, the only symbol that can be used for a composite network are the fixed standard symbols that looks very similar to what I have highlighted here. In ETAP 14, we will have now the ability to customize the look and feel of a composite network, how it is represented on your overall one-line diagram. So what I'm going to do here is I will quickly switch over to edit mode, place a composite network right here on my one-line diagram. The reason I want to create this composite network is I want to take the contents that I have highlighted here, these 750 kVA transformer and the two loads that it feeds. I want to put those inside this composite network so I could better organize my one-line diagram. So again, just open the composite network, right? We'll go ahead and highlight the elements, put them inside the composite network. Now, one of the enhancements in composite networks is you no longer have a fixed number of pins, so there is no limitation on how many external pins you have. You could see here that if I connect inside the composite network, ETAP will automatically open my composite network. I can then simply connect the load side of that circuit breaker to my two winding transformers primary. And as I mentioned, the number of external pins is now limitless. There is no limit on how many pins you may have connected to a composite network. The reason why you see these dots here is because now you have the ability, right, to increase the size of a composite network. Why you may want to do that? I want to now put a preview of the contents of that composite network. So I want to have a picture of what is inside that composite network. I want to go ahead and put a picture of my contents, basically. So what I'm going to do is I'm going to go ahead and close my composite network here. I will right-click on my composite network, go over to my symbol, and I will select symbol, and I will select the ability to preview now my contents inside composite network. So now you can see here that you have your overall one-line diagram, and if you want to quickly glance at what's inside the composite network without ever opening that composite network, you now have the ability to preview that. Additionally, for composite networks, you also have the ability of connecting or displaying pictures. So if this actually fits a UPS DC loads here. So what I'm going to do is I want to display a picture of the actual UPS. So what I'll do is quickly go over to symbols, select attach a picture. I should have my UPS, took a picture of that UPS and it's sitting right here in the background. There's a UPS. There it is. So you could attach that and either overlay it on top of your composite network, or you could put it just to the side of the composite network. So it's you could customize how you want to place a picture of that overlays on top of a composite network. Another enhancement that is part of ETAP 14 is the ability of actually connecting a system, or let me go ahead and turn off UPS, connecting a diagonal. So now I could have, instead of just having a 90-degree angle for my connection lines, I now have the ability of having a 45-degree angle, or just having the ability to connect elements in diagonal shape. I want to go over also the the ability of, there's just a quick screen capture of how a branch can now be connected diagonal. The new symbols, I want to go over the menu that allows you to select different sizes and different symbols for the various elements. So you can see now how the elements are now broken down into IEC column on the left, ANSI column on the left, and IEC column on the right hand side. And you have the ability to now pick and choose different sizes individually for each one of your elements. There is also, moving on to the next module, the short circuit analysis module, there's now also the added short circuit result analyzer. So for those of you who may have various configurations on your facility, so for example, this particular project has 3 different operating configurations. One of them is being fed from the utility. The other configuration is being fed from both the generator and the utility. The third configuration being no utility, just islanding mode, simply from the generator. We now have the ability of comparing those 3 reports and figuring out what the worst case device duty would be, right? The short circuit result analyzer is able to be launched from the right hand side, and it would display all of your different fault scenarios. So for example, I will quickly create a new configuration here. I'm going to call this island mode. There it is. For islanded mode, what I need to do is I just need to open this main medium voltage breaker. I need to go ahead and close this tie right here. And I need to isolate T2. So I'll go ahead and isolate that. And I will create a brand new short circuit analysis report called island mode. So now I have 2 different, oops, I forgot to isolate the primary side right here. So I now have 2 operating modes, one normal, which takes into account both sources, and another one called islanding mode. When I open my short circuit result analyzer now, I could see side by side both of these reports. So I'm showing here my island mode report on the left and my short circuit normal report just below that. The first column that you see on this short circuit duty analyzer is the name of all of the locations, all the buses. Over on the right hand side, you have the nominal system voltage, which can actually be sorted, right, from low voltage to medium voltage or from medium voltage to low voltage. So there's my main bus at 34.5, medium voltage all the way down to my low voltage equipment. And then the last two columns is comparing my three-phase volt as per ANSI on the maximum short circuit current. There is the capability of selecting worst case. So when you click on worst case, you could see how ETAP will pick and choose, right, the highest or the worst case, the highest voltage fault for each one of your locations. So with the short circuit result analyzer, you'll be able to save many man hours trying to sort through various short circuit reports, trying to get the worst case device duty. So I'll go ahead and close out of the short circuit result analyzer. The other item I want to go over is the ability now to search your protected devices. If I open this fuse and I go over to my fuse library, you could see how it is now in a spreadsheet format, very easy to search. So for example, if all you're searching for is Busman fuse, you could begin to just type the name of the manufacturer. ETAP automatically filters out any manufacturer that begins to match your search criteria. So in this case, ETAP automatically selects Busman right before I even complete the entire name. And now I'm giving only a list of Busman devices. From here, you can narrow by voltage. So if I'm only concerned with, for example, medium voltage, right, 5.5 or 13.8 fuses, or 15.5, then you could begin to quickly just begin to type your maximum or the cartridge voltage rating, and you could see here all of the available models available at 15.5 kV. Over on the right hand side, you have the cartridge size. You pick your cartridge size, and ETAP will automatically grab that from the library and attach it. So the search capability for your protected devices is now greatly enhanced. The other item that I want to go over is the ability to open and close your protected devices. Let me go ahead and change this back to the normal mode. Again, continuing in ETAP 14, you still have the interlock logic for your elements. So what I'm going to quickly go over, and this is great not just for design or planning purposes, but actually to have ETAP in operations. So your operator can actually have now a copy of ETAP using the following feature. I want to check, so before an operator is able to de-energize main bus, the voltage needs to be checked to make sure it is not, there is no voltage. To do that, what we're going to do is we actually place logic inside the interlock tab. What we're saying is we're basically making sure this bus is isolated. If this bus is not isolated, then ETAP gives us a warning, very similar to the alerts that we're used to for load flow or for device duty. If I try to close that ground switch, right, to test that it is in fact de-energized, so if I ground it, ETAP will automatically check the logic that I place inside the interlock and give me the following error saying that if I was to close this switch, it would be on a hot energized location. So what the operator would then do is begin the switching sequence, right? So I need to isolate my main bus. The first thing I want to do is I want to close this tie down here on the bottom left. I can then begin to isolate that bus by putting this transformer out of service, T2 over on the left hand side. Then the 3-winding transformer, let's go ahead and put that, isolate that. And finally my utility, right? So now that the utility bus is isolated and we have transfer the load through this tie, we can now, the operator can now check, right? Close that ground switch. Now the bus turns into orange. You can actually modify this. You could make these, for example, green, right? And as an added bonus, right, my alert view is running in the background, so it's giving me now a couple of overload conditions, saying that my generator here is overloaded. The rating is 7.5 megawatts, but it's operating at 7.6. So the operator can see all of this, right, just by simply, opening and closing of the breakers. So that's that is the a way for the planning and design team to perhaps use ETAP in the operator room for this, switching sequence validation. The last item that I want to go over today is the ability to perform the. Give me 1 second. Let me go ahead and energize this again. Set this to my normal condition. Okay, so the last item I want to go over today as part of the, I need to close this, as part of the ETAP 14 enhancements is with TCCs, your time characteristic curves. We now have the ability to quickly, when you have a TCC created, and this is actually true for existing projects. Let me go ahead and find a TCC that has been created here. So there is a couple of TCCs for this project. There's one here for Motor 5. A lot of times you may have TCCs where your tags for your devices may not be in the best location. Maybe they're overlapping. There is now the ability to automatically, right, it's called the label auto layout. The label auto layout automatically places your protected device labels away from if they're overlapping, away from the curve, away from the one-line diagram you may have on the bottom left. So that utility is also will save you a lot of time, especially when you're batch printing your TCCs. It can save you quite a bit of time for cleaning up those existing TCC reports that you may have to do from time to time. And lastly, the arc flash analysis now has its own module. So you could see on the toolbar across the top right here, we have the edit mode, load flow, short circuit. Now arc flash gets its own module. We now have the ability to have a study case that is just for arc flash purposes. We also have the ability to, over on the right hand side, create a TCC. So if you're validating, for example, you're doing an arc flash mitigation study, and you need to, typically those type of studies involve the creation of lots of TCCs, especially for those locations where you may have large incident energy values. So now you no longer have to switch from the arc flash mode to create a TCC to star. You could create an arc flash report. So I'll go ahead and run an arc flash simulation. Need to specify right voltage for my fuse here. So you can see that right before you even perform a arc flash analysis, ETAP now has the ability to perform a device duty evaluation. That was the capability that you saw there. ETAP was checking my protected devices to make sure that the max KV is appropriate for the nominal system voltage at that location. It also checks the withstand or your interrupting rating versus the three-phase voltage fall to make sure your devices are not over duty. After this check passes, you now have the arc flash results for your various locations that you select on your study case. And if you want to quickly create a TCC inside of the arc flash study module, it's now very simple. On your arc flash toolbar on the right hand side, you can now create a TCC. I'll go ahead and clean this up a little bit. There it is. What I'll do is I'll go ahead and take any questions you may have. I'm going to go ahead and open the questions here. If you have any questions, please put them on the questions box, and I'll go ahead and take all those in the next 10-15 minutes. Thank you everyone for attending the ETAP 14 enhancements, trick and tips. This version of ETAP will make your power system analysis a lot easier to perform, much more efficient. If you have any questions, be sure to give us a call. Thank you. Bye-bye.